everyone, welcome back to the channel. Now, we are going to dig deep into mastering the art of learning and problem solving. Today, we are going to talk about something that's a game changer, whether you are tackling math, science, or everyday challenges, problem solving, and reasoning skills. So in this video, we will break down some powerful strategies that can help you to think more clearly, solve problems faster, and approach every challenges with confidence. Whether you are students trying to ace the exam or someone who just looking to sharpen their mind, stick around because these tips are for you. From looking for the patterns to working backwards and using logic, I'll be walking through by step-by-step guide to boost your problem solving skills. So grab your pen, take some notes, and let's dive right into it. So let us first define reasoning. So reasoning is the process of drawing conclusions or making inferences based on information, facts, or premises that we have. Wherein reasoning is the process of our thinking through a problem or situation to reach a conclusions or making decisions. It involves using logic, evidence, critical thinking to connect ideas and draw conclusions. There are different types of reasoning, but they are all shares the goal of helping us to understand things better or solve problems. By reasoning, we can analyze situations, make predictions, and decides what actions to take. So in simple terms, reasoning is like solving a puzzle with your mind. You look at the pieces, for example, the facts, the observations or ideas that you have, and try to fit them together in a way that makes sense. It is the process we use to figure things out, whether it's deciding what to have for dinner or understanding a complex scientific concepts. So now let us have with two types of reasoning. So we have the inductive reasonings, which is inductive reasoning is the process of getting a general conclusions by observing a specific examples or sets. So here in inductive reasoning, we are conducting an approach which is bottom up, which is this is a type of logical thinking that involves making generalizations based on specific observations or experiences. It starts with noticing patterns or specific examples and then infers a broader conclusions from them. Unlike deductive reasonings, which guarantees the truth of the conclusion if the premises are true, inductive reasoning leads to conclusions that are probable but not certain. Okay, so for example, the sun rose in the east on Monday. The sun rose in the east on Tuesday. The sun rose in the east on Wednesday. So therefore, the sun always rises in the east. So by this example, so this is an inductive reasoning wherein we don't have the certainty, which is the sun will always rises in the east based on our observations, because the data that we have here right now is limited, or we cannot give conclusion by those observation that we conclude by the sun rose in the east on Monday and also on Tuesday and on Wednesday. So the key characteristic that you need to look here is there is a conclusion that is likely to be true in this statement, but there is no guarantee that it will always be true. So there is always a chance that future observations could contradict the generalizations. So bottom-up approach, as we said earlier, this is an inductive reasoning, moves from specific cases to broader generalizations. Okay, so used in everyday life, wherein we often use inductive reasoning in daily decisions, like expecting a restaurant to serve good food because it has done so in the past. Okay, so for example, if you taste a few strawberry from a bowl, they are all sweet, rather. So you might conclude that all the strawberries in the bowl are sweet. This conclusion is based on inductive reasoning, wherein, however, there is a chance that not all the strawberries are sweet. So your generalizations is based on limited observations. So in summary, inductive reasoning help us from general beliefs or predictions based on specific experiences or evidence that we have. But it does not guarantee that those beliefs or predictions will always be correct. Therefore, there is uncertainty, particularly with inductive reasoning. While when we talk about deductive reasoning, this is the top-down approach that we have. Deductive reasoning starts with a general statement and examines the possibilities to reach a specific or logical conclusions. So it moves from general to specific, unlike inductive that is specific to general. So here right now, deductive reasoning is also a type of logical thinking where you start with a general principle or premise and apply it to a specific case to reach a certain conclusion. So it works from top down, meaning it moves from a broad idea, general statement to a specific or logical outcome. If the initial premises are true and the reasoning process is valid, the conclusion drawn through deductive reasoning will be also true. Like for example, all humans are mortal. Socrates is a human. Therefore, Socrates is mortal. So for example, in this example is all humans are mortal, right? And then we identify Socrates is a human. So now we can conclude that therefore Socrates is a mortal. So as you can see, in this statement, our conclusion, it has certainty. It could happen. So certainty, if the premises are true and the reasoning is correct, the conclusion is guaranteed to be true. So top-down approach is we have with deductive reasoning, wherein it starts from general idea and works its way down to specific conclusions. Wherein yung reasoning process is valid if the conclusion necessarily follows from the premises. Okay, so now let us have another example. All fruits have seeds. An apple is a fruit. Therefore, an apple has seeds. So in this is a deductive reasoning. Since the first premise or in the first statement that we have, this is a general truth and the second statement is a specific fact. The conclusion follows logically and must be true if the premises are accurate. So in summary, deductive reasoning is a powerful tool for arriving at definite conclusion based on general principles. It ensures that conclusions are logically sound, but its effectiveness depends on the truth of the starting premises. So as we said earlier, deductive reasoning is general to specific, meaning we have general principle, general rule or theory, and applying it to a specific case, for instance, to reach a conclusions. So you start with a general rule, apply it to specific situations to reach your specific conclusions. Okay, so both approaches are essentials for different types of reasoning and problem solving. As we said, inductive reasoning helps in forming hypotheses or general theories, while deductive reasoning is used to test or apply those theories in particular cases that we have. Now let us have with comparison chart. So in comparison chart, we have the aspects for the direction of the reasoning, the certainty of our conclusion, and we have also another example and how we use that certain reasoning that we have in inductive and deductive reasoning. So moving from specific observations, example or instances to from a broad general conclusions or theory. So as we gathered our specific instances and used them to form a general rule or conclusions. Okay, so general to specific. So starting with a general principle, rule, or theory and applying it to a specific case or instance to reach a conclusion. So that is inductive. While deductive reasoning, you start with a general rule and apply it to a specific situation to reach a specific conclusion. That is why in directions of reasoning, particularly with inductive, that's specific to general. You have a specific conclusion to general assumptions. While deductive reasoning, you have general assumptions goes to specific conclusions. In the aspects of certainty of our conclusions, in inductive reasoning, as a summary, we have a probability or we have uncertainty. Unlike with deductive, we have certainty if the premises are true. Okay, so like for example, in inductive, observing that all swans you've seen are white and concluding all swans are white. Okay, so that's inductive. In deductive reasoning, all humans are mortal, which is Socrates is a human. So therefore, we can conclude Socrates is a mortal. So how do we use an inductive reasoning? We have formulating hypotheses and theories. And in deductive reasoning, we use the aspect of testing our hypotheses and theories. Okay, like for example, this one. Let us identify if this is inductive or deductive reasoning. So you can post the video and then you can think of it. What is it, inductive or deductive? Okay, so let us read the statement. During the past 10 years, an apple tree has produced plums every other year. Last year, the tree did not produce apple. So this year, the tree will produce apple. Okay, so as our observation, over the past 10 years, the apple tree has produced plums every other year. So it has a specific pattern, right? So last year, the tree did not produce apples. So it continues the pattern. So in this statement, we generalize our conclusion, which is therefore this year, the tree will produce apple. Because alternately, the apple tree produce plums every other year, right? So in this reasoning, you are using specific past observations. So the tree will produce apples every other year to predict a general outcome for the current year. So the reasoning assumes that because this pattern has held true in the past, it will continue this year as well. But take note, while the conclusion may seem likely based on the past pattern, has alternate produced plums every other year. It's important to recognize that this is an example of inductive reasoning because it it gives us, or it does not give us guarantee of the outcome. There could be other factors that can affect the tree that it weren't considered in the pattern. Okay, so that is why this is inductive reasoning. Now let us have another example. So all home improvements cost more than the estimate. So the contractor estimated that my home improvement will cost 35,000 pesos. So thus my home improvement will cost more than 35,000 pesos. So as our general premise or observations is all home improvement costs more than the estimate. Second observation that we can have, the contractor estimated that my home improvement will cost 35,000. So therefore, we can have specific conclusions. My home improvement will cost more than 35,000. So in this reasoning, you start with general rule that all home improvements cost more than the estimate. So then you apply this rule to your specific situations where your home improvement is estimated to cost 35,000 pesos. So based on this general rule, you logically conclude that your home improvement will cost more than 35,000. So since the reasoning follows logically from the premises, if the premises are true, the conclusion must be true. That is why this is an example of deductive reasoning, because you have a certain observations that all home improvements cost more than the estimate, and the contractor gave you a 35,000 for your estimated home improvement. So therefore, you can conclude that your costing for your home improvement will be more than 35,000. So there is certainty that your costing for your home improvement will be more than 35,000. That is why that is deductive reasonings. Now let us have with George Pólya. George Pólya, he was a Hungarian mathematician who immigrated to the United States in 1940. So his major contributions is his influential book, which is entitled How to Solve It, in the year of 1945. So Pólya is widely recognized for his work in the field of heuristics, which are strategies or techniques used to solve problems, wherein he gives us four approaches for us to solve a word problem. So first, he gave us to understand the problem. We need to understand the problem to identify what is given, what is needs to be found. Second is we need to devise a plan. Remember, after understanding problem, let us determine how to approach the problem using known strategies or methods that we have. Now we have a device plan. So now we can carry out the problem, which is we can execute the plan and solve the problem. And after that, after you answer or carry out the problem, you can review and also reflect by using the step 4, which is look back. So checking the solutions for accuracy and reflect on the problem solving process. Pólya work has had a lasting impact on mathematics education and the way problem solving is approached in various fields. So now here are some math problem solving strategies that we can use for us to identify or how to approach those word problem that we are going to encounter. First, we can look for a pattern. If you remember that we've discussed the sequences. Okay, so we are looking for the pattern for us to identify if we're going to have geometric sequence or arithmetic sequence by looking their common difference or their common ratio. And also we can make an organized list. So by a word problem, we can list all the givens for us to identify which formula that we are going to use. Also, we can have guess and check. As you remember, mathematics is a trial and error. So you can guess and check if your solution is correct accordingly. And also you can make a table, which is for you to have illustrative way to think about how you are going to assess the problem itself. We have working backwards by checking your answers, by substituting the value of your answer in your given problem. So that is working backwards. Use logical reasonings wherein you are using inductive or deductive reasoning. You are going to use your critical thinking skills here. And also another strategies that we can use, draw a diagram. In some part of your encountering word problems, you can draw for you to have a visualizations how the problem or how to execute the problem. And also number 8, solve a simpler problem. 9, read the problem carefully. And lastly, create the problem solving journals. Okay, so those problem solving strategies, I hope this will help you to be more effective, to be more accurate in your final answer, and do or some strategies that you can work with your word problem. Okay, so that's all for today. God bless you, everyone. Have a nice day. Have a great day. See you to the next meeting.